All right, so then example 3, let's solve 2y prime plus y equal to 3t squared. 2y prime plus y equal 3t squared. So the first thing I'm going to do is to find the solution to the characteristic equation. So it looks like r is a negative 1/2. So I only have one thing. It's only the first derivative. Don't let that throw you off. My solution then is a negative 1/2 t times some constant. Let me deal with the particular solution portion. So my solution set needs to have a t squared in it. And again, I don't know that it didn't have a t to start with or some constant. So I have to allow for all those possibilities. So my function then, my particular solution, I'm going to represent as a t squared plus bt plus some constant c, right? A linear combination of these three things. And we need derivatives of each of those. Actually, I only need that one, don't I? Because I don't have a second derivative in there. So let's fill that in. So I have 2 times y prime plus y all equal to 3t squared. That's the problem that we actually now want to solve. So let me clean this up a little bit. So I have 4at plus 2b plus at squared plus bt plus some constant. And so let's begin to equate coefficients. So keep in mind, I'm going to lump together all the t squared terms and all the constant terms. I just don't have any over here, but that's okay. So all the t squared terms, there's not but one of those. So that's easily done. A is equal to 3. So I'm through with that portion. All of the t terms. All of the t terms, I'm going to lump together, and there are no t terms on the other side. So I'm left with 4a plus b equal to 0. But I can make use of what I just found for a. So it looks like b is a negative 12. And then finally, I've got some constant terms. 2b plus c equal to 0. But again, I know the value of b. So it looks like c is going to be 24. So my particular solution then for that problem ends up being 3t squared minus 12t plus 24. So our solution set to this entire problem then, y as a function of t is some constant e to the negative 1/2 t plus the particular solution. Okay, so I've got 4 problems I would like for you to work for homework. Let me talk about the only other thing that will happen on these. The work is the work, the solving is the solving, so none of that's going to be too bad. Let's pretend, though, that I got functions of this nature. And let's say that on my in my original problem, I've got y prime, y double prime. Let's say it was equal to this. All right, I want new solutions to these, right? So as I look for my solution set, typically I need that e to the t in there. Actually, for this problem, that would be all, wouldn't it? E to the t. But I've already got an e to the t solution, so we need to modify the solutions. And to modify it, we do just like we did with the repeating root. I'm going to put in an extra t, e to the t. So I'm not going to use this solution set for this problem, and I've just made that up. I'm going to use this solution set. Okay, the same thing is going to happen if we need to modify anything. For instance, if I had, if in my characteristic equation, I'm just trying to think, E is about the only thing that would happen. Maybe an imaginary root. But maybe in the original problem, it was equal to 5 cosine t. So I would start out by making my set for cosine. But since cosine is already a solution, then I would need to modify that set and do t's times each of those. Which, keep in mind, that can, and I hadn't worked with the homework yet that I've assigned, maybe they'll be okay, that can complicate your derivative. So this linear combination is not bad, right? AT sine cosine plus BT sine t. But when I go to take those derivatives, I've got product rules going on in there. So just keep all that in mind. Don't throw out your calculus by any means. All right, so I'll leave those for you to work and a handful of problems to work. These can be a little lengthy, so there's not maybe 3 or 4 to work at the most.